Hey, mathematicians, it is week 13. We are getting started on our Monday column, and we are starting in a familiar place from where we were last week. So let's get started. Write an expression to find how much of the square is shaded. Let's take a look at our rows. How many rows do we see? One, two, three, four, five. There are 5 rows. And how many of those rows have shading? One. So we see 1/5 as our first factor. Now let's take a look at the columns. And we're going to see that we have 1, 2, 3, 4, 5. We have 5 columns. How many of those columns have shading? One. So really, both of our factors here are 1/5. 1/5 times 1/5. That is our first question. Now we're going to think about Dwayne the Walk Johnson. He cooked 5 kilograms of noodles in how many pots? 7 pots. Each pot had the same amount of noodles. How much was in each of the pots? That's what we're trying to decide. What was the thing that was being broken up? It was the 5 kilograms of noodles. And those 5 kilograms of noodles were being sorted into how many groups? 7 groups because we're putting it in 7 pots, right? So I see 5 divided by 7, which is the same as 5 divided by 7. You don't have to write it out like this, but I certainly like to remind you that really fraction is a teeny tiny division problem, which is really the heart of this question. Now, down here, the situation changes. It says, what if you cooked 10 kilograms of noodles in the same pots? So, what changed, boys and girls? What changed was this. It wasn't 5 kilograms of noodles, it was 10 kilograms of noodles. Is it still being sorted into 7 groups? Absolutely. We're still putting it in the 7 pots. So, here now the situation has changed, and we're seeing 10 divided by 7 or 10 kilograms. Now, let's go to our next question, a volume question. We're getting really good at volume. Certainly, all of this practice is helping our math brain to see how to calculate volume with proficiency. I'm going to take a look at this top box or prism, and I'm going to take a look at this second prism, and we're going to be adding those volumes together to get our overall volume of these two prisms over top of each other, right? Well, here, those dimensions are labeled nice and easy to see. I am seeing 18 for my length, I am seeing 4 for my width, and I'm seeing 2 for my height. So really what I'm looking at here is 18 times, well, 18 times 8, however you solve it, whatever your favorite strategy is that we should see on your paper, we are looking at 144. And it's 144 what? 144 centimeters cubed. Now, that's just the top box. Is the top box going to be smaller or greater than the second? Well, sure, it's going to be a lot smaller. This second box is larger, so we're going to find a larger volume down below. So let's take a look. We're still going to be multiplying together those 3 dimensions. Let's locate those on our shape. We are seeing a length of 21. We are seeing a width of 7 and a height of 9, right? Once again, boys and girls, I want us to be thinking mathematically, especially at this point. We're at week 3 in our year, right? We're about a third of the way through our fifth grade standards. So use your favorite strategy to multiply these together. Then pause your video and let's check and see if we got to the same answer. I know that I'm going to have 21, and I know that's going to be times. 7 times 9, of course, is 63. So really the heart of this question is, what is 21 times 63? And 21 times 63 is 1,323. Now, what am I going to do at this point in this question? I'm going to be adding this number and this number. And to be precise, I really should down below say that those are cubic meters. Okay, we're going to be adding those together. I'm going to come to the side and do that. I've got my 1,323. I have my 144. When we add these together, we have 3 plus 4 is 7, 2 plus 4 is 6, 3 plus 1 is 4, and 1 plus nothing is 1. Our answer is 1,000. 467 meters squared. How funny. Take a look. This is where I noticed that really we have centimeters up here and meters on the bottom. So I really think this meter is the one that I'm going to change just to make them consistent. I'm going to change this to centimeters cubed. Once again, this is a lot of work for the maker of this to make these for us every day. Little accidents happen, but I'm going to go ahead and change the ink stem to say centimeters so that we're consistent. Now let's look here. What is the area of the shaded region? Well, first of all, let's take a look and let's see how many single squares we have. We have 1, 2, 3, 4, 5, 6, 7. So what I'm noticing is that there are 7 squares shaded. I'm going to go ahead and start my answer here because already, just with looking at that, I'm already starting to analyze what my answer will be. Now, a whole is going to be what? A whole is not these two. Let's be really precise. A whole would be this and this. So how many are in a whole? Well, it would take 4 to make a whole, right? So I'm going to note that here. I'm going to say that 4 smaller rectangles, or I could say smaller squares, just to keep it consistent with what I've already said. Either way will work. 4 smaller rectangles equal 1 whole, right? So now I'm going to think, okay, well, really, these 4 right here, 1, 2, 3, 4, there's 1 whole, right? And then look, I have 1, 2, 3 of the 4 that it would take to build the next hole. So really my answer here is 1 and 3/4. And the reasoning is already underneath it, right? I have 3 1/4, and that's because 7 squares are shaded. 4 smaller rectangles or squares equal 1 whole. So that's where I got to 1 3/4. Okay? Really, we could say that we have 7/4, which is the same thing as 1 3/4. There could be even further explanation for how I got my answer. I'm just going to put a big arrow. You know me, I like to write nice and big. So I just went ahead and wrote out my answer there. I have done what it asked. I gave my answer and I explained. Now, I love these questions down below. This really helps us to see we are not just calculators, we are mathematicians. We are thinking about if our answers would be greater than, less than, or equal to what is listed over here. So we're not just solving, we're thinking mathematically. Now, what I'm thinking about is how does this expression compare to 50? Well, even if I just had 10 times 5, I would already be at 50, right? But I don't just have 10 times 5. I'm also going to have 1/10 times 5 more than 50. So because of that, I know that I need a more than symbol because this expression is greater than 50, right? Even just the 10 times 5 would already be at 50. And then we have 1/10 times 5 more than that. So that's why we're going to have that greater than. Okay, let's take a look at this one. We're comparing this expression to 31, okay? Well, if I had 3 times 10, I'm going to write this one out for us. If I had 3 times 10, what would that give me? Well, that would give me exactly 30, right? But I don't just have 3 times 10. I also have 1/3 times 3 more. Well, 1/3 times 3 is going to be what? 3/3. 3/3 equals 1 whole. So we would have 30 plus 1 more, which is exactly 31, which is why for our second part of this question, we need an equal to symbol, right? Now let's go down and let's take a look at our third question for really our third part for question 5. I want to know how does this compare to 80? Well, I'm looking at 9 9/10, which is just a little less than 10, isn't it? It's 1/10 away from being 10. So it's a little less than 10. Well, if this was 10 times 8, it would be exactly 80, but it's not that. It's a little less than 10. So because of that, I know that my answer will be a little less than 80 because that would be what I would have here if I were looking at 10. And that finishes our